Today's lesson is index equations, and this is a new kind of equation that we can learn how to solve. But first, let's recap. Something like 2x plus 1 equals 5 is a linear equation, and we know how to solve that. Something like x squared minus 7x plus 10 equals 0 is a quadratic equation, and we know how to solve this as well. In both cases, you will notice that x is in the base. An index equation is an equation where x is in the power. For example, 2 to the power of x is equal to 8. This is called an index equation because x is in the index or in the power of 2. And you can probably see how we can solve this. Immediately, it's apparent that x equals 3. And the reason is simply because we know that 2 to 3 is 8. But there's another process that we've been doing in our heads, perhaps without really being aware of. And this is the process that we're going to use to solve index equations. And the process goes as follows. Consider 2 to the x equals 8. Look at the bases, the 2 and the 8. We know that 8 is a power of 2. So really, we're talking about 2 to the x is equal to the power of 3. And now we have the same base. We have an equality. Therefore, this implies that x equals 3. We can immediately write x equals 3. Similarly, 5 to the x equals 125 can be written as 5 to the x equals, we know that the 125 is 5 cubed. Therefore, by comparing the indices, x equals 3. This is only possible because the bases are identical. So the key to solving index equations is to express both sides to the same base and then compare the powers. If you want to consider 3 to the power 2x plus 1 equals 81. Well, we know that the 81 can be written as a power of 3. So 3 to the power of 2x plus 1 equals 3 to the power 4. The bases are the same. We compare the powers. So we write 2x plus 1 equals 4. We write it without the bases because we established that the powers must be the same. We write a new equation using the powers only. This leaves 2x equals 3, and therefore x equals 3 over 2. Taking this one step further, 3 to the power 4x minus 1 times 9 to the power of 2x is equal to 27 to the 6. This too is an index equation because the powers contains x's and the bases are constant. But we notice that the bases are all powers of 3. So we can rewrite our equation as 3 to the 4x minus 1 times, instead of the 9, we write 3 squared, all to the power of 2x equals, instead of the 3, we know that it is 3 cubed to the power of 6. And this results in 3 to the power 4x minus 1 times 3 to 4x equals 3 to the 80, applying the laws of indices. Now we have the same basis here. When we multiply, we need to add the indices. This gives us 3 to the power 8x minus 1 equals 18. The 3 to the power of 18. Same base on both sides, so we can compare the powers, and that gives us 8x minus 1 equals 18. Therefore, 8x equals 19, and finally, x equals 19 over k. And the last example for today is 5 to the power of 2x times 25 to the power of negative x plus 3 divided by 125 to the power of 4x is equal to 5 to the x plus 1. Again, we notice that the bases are all powers of 5. So 5 to the power of 2x times the 25 is our 5 squared to the power of negative x plus 3 divided by 5 cubed to the power of 4x equals 5 to x plus 1. Applying the rule of indices, 5 to 2x times 5 to the negative 2x plus 6 divided by 5 to the 12x is equal to 5 to the x plus 1. Now we apply the rules of indices on the left hand side. We add those two powers and we subtract this power. So 5 to the power of 2x minus 2x plus 6 leaves me with 5 to the 6. Divided by 5 to the 12x means that the power is 5 to the power of 6 minus 12x equals 5 to the x plus 1. Therefore, the bases are the same, so the indices must be equal. 6 minus 12x is equal to x plus 1. Rearranging gives us 5 is equal to 13x, so x equals 5 over 50. Now certainly, it is possible to do some of this work in less steps. I'm just demonstrating the details. If you feel confident, it's okay to do some steps in your head. That's the basic idea of index equation.